All right, everybody, welcome to week one. We're going to talk about today the next step after particle theory. So we're going to look at what's called the atom. Now, you have a bit of an understanding of this already. We've already talked a little bit about it, but we're going to go into it in a little bit more detail. All right, so first lesson is models of the atom. So we're going to look back at particle theory, a couple of reminders. All matter is composed of tiny particles. Every particle of a pure substance is the same. Particles of different substances are different, etc., etc., etc. Those are the main ones. All right, those are the ones that we really want to focus on. Now, let's take a look at this bar of gold. If we look in really, really closely, if we take a look at each of the particles, what do you notice about them? I'll give you a second. Well, you should notice that they all look the same. Right? Same size, same shape, same color. Well, what about water? So we've got here a diagram, kind of a sketch of what water particles would look like. What do you notice about each of these? Well, every water particle is made up of the same three particles if we look at them closely. And those three particles are the same in every water particle. So we've got one big blue particle, and we've got two small yellow particles. Now, if we take a look at all of those particles, why were they all drawn differently? What was the point? Well, why were some bigger? Why were some smaller? Why were some different colors? Well, that's because every different colored or sized particle is supposed to represent a different particle. So the question then becomes, if those particles are different, what makes them different? Why are they different from each other? So that takes us into a bit of a history lesson. Up until now, you guys have learned the particle theory. That takes us up to about the early 1800s. So we're talking about over 200 years ago, we had an understanding of the particle theory. But obviously, we've learned a little bit since then. So we're going to talk a little bit about what has been proposed in the last couple of hundred years. So this is kind of an overview of what we're going to look at, but don't worry, we're going to take it one little step at a time, so don't worry about that being a lot of information for now. All right, so we'll start off with, in 1803, a man named John Dalton, and in 1803, he basically proposed the idea of what is called now the atomic theory, and really he didn't change anything. Right, so we already had an understanding of the particle theory. He just decided to call those particles atoms, and he took that name from the Greek word atomos, which means indivisible. So his idea was that these particles that we've been talking about, we're going to call them atoms, and they're just tiny individual particles that are indivisible. But as it turns out, Dalton was actually completely wrong about that part of it. But we didn't really figure that out for another 100 years. So in 1803, Dalton came up with this idea, and then it wasn't until 1904 that a scientist named J.J. Thomson started proposing some changes. And his idea was that it wasn't just a solid particle that was indivisible, but there were actually smaller parts to it. So those are what are called subatomic particles, so sub meaning smaller. Right, so he still kind of thought of the atom as basically being, a round spherical type thing, but he thought of it more of like a cloud with a positive charge, and that positive charge was spread out evenly through the particle. But he also thought that there were these tiny little subatomic particles that we now call electrons that have a negative charge. At that time, he called them corpuscles, but we now call them electrons. So this was the first time somebody had come up with the idea that there might be something actually smaller than the atom, so subatomic. Now, the model that he proposed is what's called now the plum pudding or raisin bun model. Kind of depends on where you're from, which one you refer to. And it's basically because the model kind of looks like, when you draw it, a raisin bun or plum pudding. So around that time, another scientist named Hantaro Nagaoka, and yes, I did learn how to pronounce his name properly, came up with a slightly different variation on it. Now, as it turns out, his idea is actually probably closer to what the atom actually looks like, but he really doesn't get a whole lot of recognition. So his idea was that instead of this plum pudding idea where it's like a solid or like a spherical structure with tiny negative particles kind of embedded through it, he actually thought of it more like Saturn. So it's called the Saturnian model because it looks like the planet Saturn, and it has this positive sphere in the middle with an actual ring of electrons going around it. So that actually turns out to be a little bit closer to what reality is than Thomson's plum pudding model, but because Thomson came up with this idea of the electrons, he's more recognized for this next step. So that was 1904. 1911, Ernest Rutherford took Thomson and Nagaoka's contributions a little bit further, and he started looking at not the electrons, but the protons. And he performed what is called the gold foil experiment. And we're not going to get into any details on it, but what he found out from that was that instead of it being a large sphere of this kind of positive cloud, this positive charge spread out through it, it's actually really, really, really tiny. And they call that the nucleus. Now, what he further figured out a couple of years later, 1920, is that if you were to take a hydrogen atom, and we'll learn a little bit more about hydrogen as we go further on, and you look at just the nucleus of it, it actually turns out to be just a single positive particle. And he called that a proton. So that became our second subatomic particle. So we have an electron that Thomson came up with. So it's a tiny negative particle. And we now have a proton, a tiny positive particle. Now, as far as size goes, protons are significantly bigger and heavier than electrons. But as far as how strong they are, it's about the same. So while protons are much, much bigger and heavier than electrons, their charge of +1 is about as strong as an electron's charge of -1. So if you were put them on a scale, the proton would be significantly heavier, but the electron's small and mighty. So, next step, 1913, a man named Niels Bohr. And Niels Bohr would continue to contribute to science for many, many years. He actually is one of the founders of what's called quantum theory. And he started in 1913 with looking at electrons. And this kind of takes Nagaoka's idea of the electrons being in this ring around the nucleus a little bit further. Rutherford looked specifically at just the nucleus. So Bohr started looking at, okay, we've got a good idea of where this nucleus is and what's in it. So where are these electrons actually going to be found? So what he figured out was that they're not just in this one single ring. They actually are in several what are called energy levels around the nucleus. And if you look at the diagram, you can kind of see kind of an idea of what it kind of looks like. And we refer to those as electron orbitals or shells. So you'll hear that, or either one of those terms used quite frequently. Grade 10, you look at it quite a bit more, all right? And then finally, we have another person, another scientist who doesn't really get a whole lot of credit for anything, but a scientist named James Chadwick in 1932. So Bohr contributed this component of it in 1913. It wasn't for almost another 20 years that another scientist actually figured out, okay, we had protons and electrons, but we're missing something here. And what he discovered was that there was actually another subatomic particle called the neutron. Now, neutrons were kind of missed because they don't have a charge. They're neutral, hence the name neutron. But they're heavy. And in fact, they are about the exact same, well, not exact, but they are pretty close to the same mass as a proton. No charge, but around the same mass. Now, as far as what they do in their effects, we don't really care about most of it, except for the fact that it makes it heavier at this level. If you were taking, grade 12 physics or going into university level physics stuff, then you would look at how it affects radioactivity. But as far as what we're looking at, all we care about is that it just makes them heavier. All right. So the mass of one neutron is about or approximately the mass of one proton. Okay, so there actually is quite a bit more to the history of the atom, but we are going to stop at that point. We don't really need any more to do what we need for this course. All right. So summing it up so far, particle theory has now become the atomic theory. The particles from the particle theory we now call atoms instead of just generic particles. The atoms are composed of 3 subatomic particles. Electrons, which are tiny, and they're found in orbitals around the nucleus, and they have a negative charge. Protons are heavier. They're found in the nucleus. They have a positive charge. Neutrons are also heavier. They're also found in the nucleus, and they have a neutral charge. This is kind of what it looks like. All right, so this is what's called the Bohr-Rutherford model of the atom. You can see in the middle, we have protons, which usually we have the symbol, P or P+. Neutrons, the symbol N or N0 or N0. So those we're going to find in the nucleus. And then around the outside, we have electrons. And the symbol for that is usually an E with a negative sign on it. And those electrons, you can see, are at different levels or different shells. Now, take a good look at that. And does that look familiar to you? Well, it kind of looks like this. And the idea is kind of the same. So this is a model of the solar system, and we'll actually spend some time looking at what this looks like later on in the course. But if we're to compare the two, solar system has a heavy, heavy sun or star in the middle, and it's got the smaller, lighter planets revolving around it. Same idea with the atom. So the Bohr-Rutherford model of the atom, we've got the heavy nucleus in the middle, and that is composed of the protons and the neutrons in the middle, and we've got the smaller, lighter electrons revolving around it.